Today we discuss one important problem related continuity of this function. Okay, we'll write this function here. If x equal to 0, x belongs to r difference q, and if x equal to 1 by n, x equal to m by n, that means x belongs to q. Okay, so we talk about here. We prove that what we prove. We prove f is continuous. F is continuous at every irrational point. At every irrational point. Okay. And if has simple discontinuity. If has simple discontinuity at every rational point. At every rational point. Okay. So we now are going to proceed solution of that problem. Okay. Now also write in this way. We taken one sequence xn. Okay, xn sequence from r difference q. That means irrational number, sequence of irrational number. Okay, sequence of irrational numbers. Understood? Sequence of irrational number. Now xn converts to c. Xn converts to c, and c obviously where c belongs to r difference q. Okay. Then what happened? Then we write here f of xn equal to 0 and f of c equal to 0. Then not a problem at all. We write in this way, f of xn converts to f of c. Okay, not a problem at all. Then we also here discuss another one. That means this xn converts to c. Okay, xn sequence of xn sequence of irrational point. Okay, sorry, sequence of here rational numbers. Okay, we talk about another way where xn sequence of rational number. Okay, rational number. Then what happened? Then this c belongs to this, c belongs to our difference q, and xn belongs to this q. Then what happened? F of xn equal to what? F of xn equal to here, if x belongs to m by n, then 1 by n. Here 1 by n, where xn equal to mn by n. Okay, and here f of c equal to what? F of c equal to 0. Then what do we get? We get as n tending to infinite, as n tending to plus infinite, f of xn tending to f of c. Okay, that means 1 by n tending to 0. We write here 1 by n tends to 0 as n tends to plus infinite. Okay, so not a problem at all. In this way we see that any sequence taken from irrational or any sequence taken from rational obviously converts to any irrational point. Okay, c belongs to our difference q. That means any sequence of real number converge to one irrational point, then we see what f of xn converges to f of c. Okay, so we write in this way here. We add that portion and going to discussion of that. Okay, that means xn the sequence of real numbers, then what we see xn be a sequence of real numbers. That means either irrational or rational converge to any irrational point C, then f of xn converges to f of c. That means f is continuous. Okay, not a problem at all. So we now discuss another part. Okay, that means any sequence converges to a rational point, then what happens? Okay, that means one part also proved f is continuous at every irrational point. Okay, that means in irrational point this one is continuous. So we erase that portion and going to further discussion of that. Okay, so one conclusion is done. We write here that is f is continuous at every irrational point. Understood? C belongs to irrational, so that is done. Now we're going to same procedure. We take an yn be a sequence of irrational number. Okay, irrational number. And obviously we also talk about here yn converts to same c. Okay, and c belongs to q. That means c r n q. Then what happened? We write it now. F of yn equal to 0 and f of c equal to what? Greater than 0. Okay, then again we also write in this way yn be a sequence of rational number. Then what happened? And obviously here yn tends to c and c belongs to q. Then we write here f of yn equal to what? Greater than 0. Okay, and f of c equal to greater than 0. Okay, but in this way we write f of yn equal to what? Yn equal to something mn by here n. That means f of yn tends to 0 as n tends to infinite. Okay, so f of c not equal to 0. F of c, that means if sequence of irrational point, then this one greater than 0, and if sequence of rational number, then this one greater than 0. So we talk about that. Here we take an yn sequence of be a sequence of real numbers. That means either rational or irrational. That means real. Then what happened? Then yn converts to c and c belongs to q. Okay, that means sequence of yn, sequence of real number converts to any rational point. Then f of yn tends to 0, but f of c greater than 0 always. Okay, so we done conclusion here. We write conclusion, that is f is not continuous at c belongs to q. Understood? That means we done another conclusion part here. Okay, f is not continuous at c at rational points. Okay, at rational points, since c is arbitrary. Okay, so at rational point, now we also erase that person. That means how we remove that irrationality, that continuity. Okay, that means if we take c belongs to q, okay, and for which if c are 0, okay, then what happened? Then if c are 0, then what happened? Then obviously, that means then if be continuous. Okay, but this one is not possible here. Okay, just we take if c equal to 0, then this one, then that means if be continuous, but here if c not equal to 0, here if c belongs to that means here if c always greater than 0. Okay, so we call if has simple discontinuity. Okay, that means just we remove this point, that means point value of function, then we also remove this discontinuity. Okay, so we call it simple discontinuity at every rational point. Okay, rational point, not a problem at all. I think all are understand this one easily. This one important problem related to that means continuity of any function. Okay, so I think all are understand this one easily. Fx continuous at every rational point and if discontinuous at every rational point, and this discontinuity, I think simple discontinuity. Okay, that means if we just fc, we also write fc equal to 0, or we also put here fc equal to 0 for c belongs to q, then this one are f continuous, but this one not possible, so we call it f is simple, f have simple discontinuity. Okay, so today I stop here. If you get this type of video, please subscribe my channel, follow my channel, see this video regularly, click on like options. Okay, thank you.